Welcome to the Deep Dive. Ready for an incredible journey? We're diving into the history and mysteries of the universe.
We're talking fascinating facts, mind-boggling theories, stuff that'll leave you looking up at the night sky with a whole new perspective.
Think of it like piecing together a giant puzzle, one that's been billions of years in the making.
Exactly. And we've got some amazing pieces to work with today. Articles from Astronomy.com, BBC Sky at Night magazine, even some insights from World Science U.
We're your guides through the cosmos, highlighting the most incredible discoveries and those mysteries that keep astronomers up at night.
And you know what better place to start than right here in our cosmic backyard, with our very own moon.
Always there, shining in the night sky. But its formation, that's a tale full of surprises.
Cosmic drama, really. For decades, scientists were baffled by the Earth-Moon system.
I mean, you look up and see that familiar face and you don't think twice, right?
Yeah.
But the moon's story is way more complex than you might imagine.
It really is. Think about it. Why is the moon so large compared to the Earth? Why that strange tilted orbit?
And those rocks brought back by the Apollo missions, so different from anything we find on Earth. It's like, where did this thing even come from?
Early theories tried to explain it. Some thought the moon was just wandering through space and got captured by Earth's gravity.
Just having to get snagged, huh?
Others imagined Earth and the moon forming together side by side, like a double planet system.
Okay, I can kind of see that.
There was even an idea that the early Earth was spinning so fast.
Like a cosmic figure skater.
Exactly. And it spun so fast that a chunk of it flew off and became the moon.
A cosmic breakup.
Yeah.
Talk about starting your own orbit. But I guess none of those ideas really fit the evidence, huh?
Not quite. It wasn't until we got our hands on actual moon rocks that the real story began to emerge.
Those Apollo missions, talk about a giant leap for science.
Absolutely. Analyzing those lunar samples, scientists discovered something incredible. The oxygen isotopes in moon rocks, practically identical to those found on Earth.
So same oxygen fingerprint. What, like they were twins separated at birth?
Essentially. It meant they had to come from a common origin. And that led to a whole new theory, the giant impact hypothesis.
Okay, now we're talking. This sounds dramatic.
Imagine this. A massive object about the size of Mars
That's not small.
slams into the young Earth. Boom! Cosmic collision of epic proportions. This rogue object, which scientists named Theia.
Thea, huh? Gotta love those dramatic space names.
Right. So Theia smashed into Earth with incredible force. The impact sent debris flying everywhere, a cloud of molten rock and dust surrounding our planet.
I can't even imagine the energy involved in something like that.
It's mind-blowing. And out of that chaos, the moon was born. Gravity pulled that debris together, shaping it into the sphere we see in the night sky.
Destruction and creation on a cosmic scale. It makes you wonder, what if Thea had missed? What would our nights be like without the moon?
It's a fascinating thought, isn't it? But for now, let's shift our focus from the moon to our planetary neighbors, Mars and Venus.
Oh yeah, worlds that have captured our imaginations for centuries, full of mysteries and surprises.
Absolutely. Places that make us rethink what we thought we knew about the universe.
So we've got planets and moons. But now, let's venture out a bit further, into the realm of galaxies.
Really big stuff.
Right. I remember looking at the Andromeda galaxy through my telescope as a kid. Just this faint smudge. But it's actually a massive spiral galaxy, much like our own Milky Way. And get this, it's on a collision course with us.
It is a cosmic dance billions of years in the making.
Billions, wow. And that faint smudge, it's 2.5 million light years away. Think about that. The light we're seeing now left Andromeda before humans even existed.
It really puts things in perspective, doesn't it? The vastness of space and time.
It does. 2.5 million years. Wild. But okay, let's talk about this collision. What happens when two galaxies, each with billions of stars, decide to, have a little get-together?
Well, it's not a head-on crash like you might imagine, more of a slow, graceful dance. Galaxies will pass through each other, their gravity pulling and tugging at stars and gas clouds.
So kind of a messy dance.
You could say that. Over billions of years, they'll merge. Spiral arms intertwining, eventually forming one giant elliptical galaxy.
A whole new galaxy. Incredible. Some astronomers even gave it a name, right?
They did. Milkomeda.
Milkomeda. I kind of like it. But it's hard to even grasp the timescale we're talking about. Billions of years. It makes you feel pretty small.
It does.
And if our galaxy is just one of billions out there, just how big is the universe itself? Is there even an edge?
Now that's where things get really mind-bending. See, the universe isn't expanding into something. Space itself is expanding.
So it's not like there's a boundary, a wall somewhere.
Not exactly. Based on what we know about the universe's expansion, the observable universe, that part we can actually detect is at least 93 billion light years across.
Okay, my brain is officially fried. 93 billion light years. But wait, there's more, right? We haven't even talked about dark matter and dark energy.
Oh, right. The ultimate cosmic mystery.
They really are. Invisible matter, invisible energy. But what's the deal with all this invisible stuff?
Well, to understand them, we need to go back a bit. Back to the 1930s, astronomers like Jan Oort and Fitzwicky were studying the motions of stars and galaxies, and they noticed something strange.
Something strange. Like what?
The stars were moving way faster than they should have been, based on the visible matter, the stars and gas that we could see.
So like something invisible was giving them an extra push.
Exactly. Zwicky called it Dunkelmaterie, dark matter. He figured there must be some unseen matter lurking in galaxies, providing the extra gravity to explain those fast-moving stars.
So not just empty space. Something else was out there, something we couldn't see. But how did they know this dark matter wasn't just some fluke, a bad measurement?
Well, the real breakthrough came later, in the 1970s, with astronomer Vera Rubin. She was studying the rotation of spiral galaxies and found that stars farther from the center were moving just as fast as those closer in.
Which is weird, right?
Very weird. If a galaxy's mass was concentrated in the visible stars and gas, that shouldn't happen. It pointed to, you guessed it, dark matter, making up the bulk of the galaxy's mass.
So this dark matter wasn't just in a few galaxies, it was everywhere.
Seems so. Measurements of the cosmic microwave background radiation, the afterglow of the Big Bang, they suggest that dark matter makes up about 26% of the universe's total mass energy.
26%, that's a lot of missing stuff. But if it's so common, why haven't we actually detected it? What is this stuff made of?
That's the million-dollar question. We know dark matter interacts with gravity, but it doesn't seem to interact with light or other forms of electromagnetic radiation. That's why it's so hard to see.
A cosmic phantom, exerting its influence but staying hidden. Spooky.
Scientists have come up with many candidates for dark matter particles: WIMPs, axions, sterile neutrinos. But so far, no luck. It's one of the biggest challenges in modern physics.
Cosmic treasure hunt. Except the treasure is invisible.
Exactly. And as if that wasn't enough to keep physicists busy, we also have dark energy.
Right, dark energy. Invisible matter and now invisible energy. What is it, some kind of anti-gravity force?
Yeah.
Pushing everything apart?
In a way, yes. Remember Einstein's famous equation, EMC2?
Mass and energy, two sides of the same coin.
Right. Well, dark energy is a form of energy associated with empty space. It's as if the vacuum itself has energy. And this energy has a very strange property. It causes the universe to expand at an accelerating rate.
Hold on, so empty space isn't actually empty. It's full of this energy that's pushing everything apart.
That's the current thinking. And it's one of the most profound discoveries in modern cosmology. For decades, we thought the universe's expansion was slowing down because of gravity.
Makes sense. Gravity pulls things together.
Right. But then, in 1998, two teams of astronomers were observing distant supernovae, and they found that the universe's expansion wasn't slowing down, it was speeding up.
So something was overpowering gravity. Something was pushing everything apart faster and faster.
And that something is dark energy. And get this, dark energy accounts for about 69% of the universe's total mass energy content.
69%. That's even more than dark matter. The majority of the universe is made of this invisible force that's driving its expansion. It's kind of unsettling, you know?
Yeah, it is. We've come a long way in understanding the cosmos, but clearly we've only just scratched the surface.
So much we still don't know. Speaking of things we don't fully understand, let's talk about black holes. Regions of space-time where gravity is so strong, nothing, not even light, can escape.
Black holes are definitely some of the most extreme objects out there.
They are. I remember reading about that famous bet between physicists Kip Thorne and Stephen Hawking about Cygnus X1, one of the first objects thought to be a black hole.
Ah, yes, Cygnus X1. A binary system, two objects orbiting each other. One is a massive bright star, the other invisible. But it's pulling material off the star, creating this disk of superheated gas that emits X-rays.
And those X-rays were the proof, right, that a black hole was there.
Exactly. The black hole's intense gravity was pulling matter off the star, and as that matter spiraled inward, it heated up to millions of degrees, releasing those X-rays.
Like a cosmic vacuum cleaner, sucking up anything that gets too close. But what happens to that matter once it falls in? Does it just disappear?
Well, Einstein's theory of general relativity suggests that matter falling into a black hole gets compressed infinitely at a point called a singularity. But we don't yet have a theory that combines general relativity with quantum mechanics.
So what happens at the singularity? It's still a mystery.
A big one. It's amazing how much we've learned about the universe, but also how much we still don't know.
It's humbling, really. But we've talked about the universe's birth, its composition, some of its most extreme objects. What about its ultimate fate? What happens to the universe in the end?
Yeah, the end of the universe. It's a question that's always fascinated me. What happens? Is there some grand finale?
Well, the current thinking is, based on what we know about the universe's expansion and dark energy, the most likely scenario is something called the Big Freeze.
The Big Freeze doesn't sound too cozy. What would that even look like?
Basically, imagine a universe where the stars slowly burn out, their fuel exhausted. Galaxies, driven apart by that ever-expanding space, get farther and farther away from each other.
So everything just spreads out, gets colder and darker. Yeah, the background temperature of the universe drops closer and closer to absolute zero.
A slow fade into darkness. Kind of a bummer ending, honestly. But wait, didn't we also talk about the possibility of dark energy ripping everything apart? Is that still on the table?
Oh, absolutely. The big rip. Much more dramatic, right? The idea is that dark energy not only drives expansion, but it gets stronger over time.
Stronger and stronger.
Exactly. And eventually it would become so strong that it overcomes all other forces, tearing apart everything. Galaxies, stars, planets, even atoms themselves.
Okay, so either a slow fade or a sudden shredding. Not great options. But let's shift gears for a second. We've been talking about the how of the universe. But what about the why? Why is there something rather than nothing? Where did it all come from?
The really big questions. The ones that have been pondered for, well, forever. And to be honest, we don't have definitive answers.
So, still a mystery.
Very much so. Some theories propose a multiverse, where our universe is just one of countless others, each with its own laws of physics.
Infinite universes.
Others suggest a cyclical model. Big bangs followed by big crunches, happening over and over again, an endless cycle.
It's a lot to wrap your head around. But here's a question that maybe, just maybe, we'll be able to answer in our lifetime. Are we alone? Is there life out there beyond Earth?
Now, that's a question that captures everyone's imagination. And when you consider the sheer scale of the universe, billions of galaxies, each with billions of stars, many with their own planets, it seems almost impossible that Earth is the only place where life exists.
Right. It'd be pretty arrogant of us to think we're that special, especially with all we're learning about the building blocks of life being out there. Water on Mars, organic molecules in those nebulae. It's all pretty exciting.
It is. And then there's the discovery of exoplanets, planets orbiting other stars. Some of them are even in the habitable zone where conditions might be just right for liquid water, a key ingredient for life as we know it.
So the search for life beyond Earth, it's heating up.
Definitely. New telescopes, new techniques,
Yeah.
all aimed at peering into the atmospheres of those distant planets, looking for biosignatures, the telltale signs of life. It's a thrilling time to be in this field.
It really is. Well, that brings us to the end of our deep dive into the universe. From the moon to black holes, dark matter to the ultimate fate of everything.
We've covered a lot of ground. And along the way, we've encountered as many questions as answers.
That's the beauty of science, right? Always more to discover.
Exactly. It sparks our curiosity, challenges our assumptions, reminds us just how much there is still to learn.
So next time you look up at the night sky, remember you're looking at an ancient and ever-evolving story, one that we're only beginning to understand.
Keep asking those big questions. Keep exploring. You never know what incredible discoveries await.
And on that note, thanks for joining us on the Deep Dive. Until next time, keep looking up.